Let's move on to flat Earth, okay? And let me start with a synthesis of what flat earthers in general believe, okay? You know, there's different kinds of people out there, and some believe in this and others believe in that. But a flat earther essentially is a person who believes that the Earth is flat, and they have something in common with Moonies. The Moonies are people who believe that humans did not land on the moon, or disbelieve that humans did land on the moon, whichever way you want to put it. But not all Moonies are flat earthers, but all flat earthers are Moonies, okay? So here we illustrate that first, okay? Here it is. Okay, all Moonies, all flat earthers are Moonies. None of them believe that we went to the moon, because if they did, they have a problem with their theory, which is that, or their assumption, which is that the Earth is flat, right? And of course, if we went not only to the moon, but we don't even have to go to the moon. We can just go out here with our satellites, take a picture of the Earth from space, and you would quickly see that the Earth is roundish, spherical, a globe, right?
That's assuming satellites exist and all, all their equipment is accurate. Right?
That's what they're saying. They're saying is that that's what I'm saying, that all flat earthers are Moonies. They don't believe we went into space, because that would destroy their whole religion. Okay, that's the issue. But not all Moonies are flat earthers. There are Moonies out there that engage in a lot of politics. They think that a lot of this is a hoax, something created by governments, that to fool us and etc. So they get it, and there's some of these are intelligent people. Okay, it's just that they have this problem with belief, because they say, I think the government's trying to fool us. They have that thing going through their mind. And so, so again, just keep that in mind. Not all Moonies are flat earthers, okay, but all flat earthers are Moonies. Anyway, here's a synthesis of what a flat earther is or believes in. This is in general terms. It doesn't involve all of them, okay? Again, you have a spectrum out there. I can't cover every little thing. All I can tell you, this is in general what a flat earther believes in. Okay, here it is. A flat earther in general engages in politics. He wants to do politics and not physics. Okay, that's the issue. He just wants to talk about hoaxes, and in that sense, they're very much in common with the Moonies. Moonies, a lot of them just want to talk about politics and not about the physics of it. Here we don't do politics as much. We do a little bit of politics, but the main course here is physics, okay? Then the other thing is that a Moonie, a flat earther, is a person who wants to do everything with what is known as classical physics. They've never advanced beyond classical physics, meaning they want to go to a lab, like you go to a lab in school, and they want to do some kind of experiment that they can see and touch with their hands, see with their eyes, touch with their hands, right there in front of them. And they say, well, show me that water curves, or, that sort of thing.
They want to be convinced by their senses, not
exactly.
their thought.
But they're direct senses, like, they don't understand what's going on at CERN, acceleration of particles we can't see or touch. That's beyond their experience. Out there, the satellites going around the Earth, that's beyond their experience. They say, I have no way of verifying that, touching it, seeing it with my eyes, like close. I can't go into space and touch one of those satellites, so therefore I'm going to withhold my belief. That's more or less where it is. They want classical physics. They want stuff that they can see and touch right here on Earth. Okay, that's part of the problem. So they have no idea of the historical progress that's happened. In other words, they don't know why we ended up with quantum mechanics or relativity, and they could care less. They just want to stay in the 19th century and before, where they said, look, all these people just did experiments like, Faraday, he did experiments with magnets. That's what they want to do. They want to limit it to that, what they can see on their desk, more or less. No, not what they're doing at CERN with billion-dollar experiments. They're beyond all that. Okay. Anyway, so space is beyond their experience. They've never been to space, so they say, don't take me out there into space. Don't talk to me what's out there, because I've never been there. I've never touched it. I've never seen it. So don't talk to me about what's out there. That's something I can see from here. Yeah, space. There's some black stuff out there.
Don't talk to me about things I don't understand,
or that I have no experience with. That's the issue. Yeah. Okay, and so they want see-touch. They want to be able to see and touch everything. They can't see the air, but I guess they take that.
They can touch that one.
Yeah, but they don't see it.
Either or, I guess.
Yeah, but they can't touch the chair that's on the other side of the planet. Like in Japan, they can't touch that one. So does that one exist? Is that an object? That's the issue. And they want to do things that are here on Earth. Okay, and that's where they want to limit their experience and their theories and their discussion, their arguments. Okay, they just want to limit it to Earth, classical, see, touch, here on my desk or in the lab, that sort of thing. They want to do experiments or they want to reproduce experiences that they've had maybe in high school, maybe in college. That's what they want to limit it to. Okay, so that other arguments are based only on that. And so they talk about practical demonstration. Demonstrate, prove to me that the earth is round, you know? And, you know, they don't want you to go out there and say, look, this is how the Greeks proved that the earth was round. The guy walked, you know, and so on, and measured. They don't want any of that. They say, prove to me here that this highway curves. That's or that I can't see the horizon because it drops below, you know, the water below the horizon or something. That's the sort of thing that they're looking at, and that's what they're going to limit you to, and they're not going to go beyond that. They're just going to stay there in that little world.
Well, I think they want to just minimize conjecture, just passing it on.
Yeah,
the following of. They weren't in front of them, basically.
Yeah, and that's why the last item there was technology. They are heavy on technology because, again, that's something they can see and touch right there in front of them. You know, they can press the button on the wall and the light turns on. So they can relate to all that because it's their everyday experience. But when you say, look, we're asking you to visualize, to understand, that's beyond my experience. Don't talk to me about imagination. I want something I can touch and see and touch, etc. So that's the starting point, and that's a bad starting point because, again, they don't understand why the mathematicians had to go from classical mechanics to quantum mechanics and general relativity. They have no idea why we made that transition and ended up with black holes, Big Bang, and all this nonsense that we have today. Okay, which is nonsense also. And I'll tell you something. I'll give you my own 5 cents worth on that. If I had to choose between flat Earth and Einstein, I'll choose flat Earth any day. Einstein is even worse because he's saying there's something called time that is warped.
Yeah.
Okay, and that there's creationism, that suddenly the universe popped out of nowhere. Of course, they don't go to that point. They always go to frame number 2 in the movie. They never go to frame number 1, which is how did the singularity get there in the first place? And that's where the religious people say, oh, God put it there. Yeah?
That's the gotcha.
God's outside of singularity. Where he's standing, I don't know. But so this is the issue. If I had to choose, I would choose flatland over general relativity, which is warp space, warp time. No such monster. So the explanations of flat Earth are, if anything, one notch above general relativity. That's
sad if you think put it like that.
Because I mean, if they spend last 100 years developing general relativity to come up with black holes, dark matter, dark energy, Big Bang, well, you know, all these people wasted their time. They did a lot of math. Maybe their math is good. Who cares? Nobody. Again, I'm going to get to that in a minute. Math has nothing to do with science. We want explanations. We want to understand how gravity works, how magnetism works, how electricity works, how the atom does its thing, you know, how light works, etc. We want explanations, mechanisms for that. That's what we don't have today. What we have today is a bunch of math and irrational explanations that support that math. That's all we have. Okay, so that's our starting point. So someone makes a comment, a flat earther, and he says the following. He says, if it's just valid explanations you want, Bill, I can do that and base it on what I can demonstrate. He wants to do some kind of magic trick on stage. He says, I'm going to demonstrate to you that I can cut the lady in half, you know, that kind of thing. He wants to demonstrate. Okay? So when you talk about out there, he said, I can't demonstrate that because I can't go out there. I can demonstrate here on Earth. You know, that water is level. You know, here we have water level in my glass of water. It's flat, isn't it? Or relatively flat. So this is the kind of experiment they want to limit their discussion to. This is where the whole problem is. Okay, so it says an explanation derived from what? Practical reference. Practical. Touch. See, touch. I'm going to take you to my lab and show you that water doesn't curve. That sort of thing. Okay, that's where they're at. That's where they're going. And they're going to go with a little experiment, which this fellow is going to raise. He says, I can say the Earth is in uniform motion. The motion relative to us would be upwards. Okay, whatever upwards is in the universe. They don't care because they're going to talk about upwards here on Earth. Like, you know, my hand is moving upwards right now, right? Moving upwards. Why? Because it's moving upwards with respect to me, the floor, whatever other reference that you use. Okay, so this is the frame that they're going to use. The reference frame saying this is upwards. They're not going to talk about upwards at a universal level. Okay, so is the sun going upwards? Downwards, you know, with respect to the center of the Milky Way, is the Earth going upwards, downward? They're not going to deal with that, okay? They're going to talk about upwards here on Earth. So he says, uniform motion dictates weight. That's just a description so far. He promised an explanation. So far, we got a description. Oh, he just made a unsubstantiated statement. That's all he made so far, okay? He says, uniform motion dictates weight. Okay, we don't know where he got that. He just invented that. We don't care if it's true or not. We're going to get the truth.
Oh, boy.
So we don't care about that. Okay, it says it creates the pressure density layers and gives us our downward vector. Again, that's a description. So far, he hasn't explained anything. He's just parroting what he learned maybe in high school or maybe just got off the internet. So he just puts it on. He just cuts and pastes. That's all he did here. Okay, an object alone in 3D space. 3D space. What the hell is that? Has no direction and no weight. Can he explain why? Oh, he's just making statements, okay? All he did is put statements, which he copied and pasted, right? He hasn't explained anything so far, okay? We need to know why it has weight. That's what we're trying to figure out. What causes weight?
Isn't he saying that the Earth is going upwards?
Well, yeah, but let's get to the example that he's got, which is interesting. Bring in a uniform moving reference frame to contact the object. A reference frame? You mean like a picture frame? Is that what you're talking about? I mean, what is a reference frame? It's a concept. You can't say a reference frame. What contacts the object? That's an irrational statement. Okay? So don't tell me about a reference frame. Tell me about a tree. Talk to me about a dog. Talk to me about a rock and say, look, with respect to the rock, or the rock touched the object. That you can say, but you can't say a reference frame touched the object or came in contact with the object.
Yeah, he lost me. I don't know what he's saying anymore.
Okay, so concepts do not touch objects or contact objects. And he continues, says, now the object has its weight and directional vector, the opposite of the action. Again, just baseless, unsubstantiated statements, no explanation, just descriptions, and he thinks that he explained something, that he understood something.
Well, I think he's trying to paint a picture, and with that, explain it.
Well, let's find out if he ever explains it, because so far he hasn't explained anything. Okay, that's my point. Okay, so far we don't have an explanation. All we have is this guy saying, look, there's weight, there's a reference frame that contacts the object. He talks...
I think by reference frame he meant like a reference object, maybe?
No, this language comes from mathematical physics. They talk about reference frames, especially Einstein. What they do is they put a stake in the middle of space. Bam, bam, bam. They hammer the stake in the middle of space, and they say, with respect to that point, that reference frame, I'm over here. This is the distance, this is the weight. They put everything in relation to this mathematical concept called reference frame or frame of reference. So it's just a concept. And again, the idea, the best analogy for it is, put a stake in the middle of space, call that a number 5, and you're 10 feet away from the number 5. That's what they're saying. Okay, and they call that a reference frame. And that's mathematically, they need that for their equations. It has nothing at all to do with physics. Physics, you can have, the reference frame had better be a physical object. Then you can reference yourself with respect to that object, not with respect to a concept called reference frame, which is a point that has location according to mathematical physics. That's either an ordered pair, triplet, or quadruplet. That's what it is. They're just going to put a series of numbers, say that's your reference frame. That's your set of XY coordinates. That's what they're talking about. So that's got nothing to do with physics. Okay, physics, you have to put a rock and say, well, my reference frame is the rock. Now you got something where you can gauge distance and whatever you want. Motion or whatever. Okay, so here's the example this fellow gives, okay? Again, flat earther, keep that in mind. So he says the following, he says, recreate the density tower. Talks about density. He thinks density is a physical object, and so do all flat earthers, okay? So they like the word density. And it says, in an accelerating vehicle, hang a helium balloon. Oh, they all love this helium balloon thing. They all bring that example. Okay, let's go with it. Let's find out where this leads, right? The air is being compressed to the back, creating more density, so the helium balloon moves forward. Okay, what is he talking about? Okay, first I ask why. He doesn't explain why. He just made a baseless statement. Okay, what is he talking about? He's talking about this. Okay, this is what he saw. And there's like a couple examples on the internet, okay? So you can look them up. I brought both of them here, okay? So you'll see what he's talking about. You'll visualize what he's talking about because it's illustrated. Here it is, okay? So this lady, she accelerates the car, and you would think that because of the inertia, the balloon should go backwards, and it goes frontwards instead. And when she stops the car, okay, instead of the balloon going forward like you would, like if you press the brake on your car, you go forward, but the balloon goes backward. So it's counterintuitive. When she accelerates, okay, she gets thrown against the car, against their seat, but the balloon moves in the opposite direction, moves forward. Okay, so this is what this guy is saying. Okay, this is where he's getting his example. Okay, and here I'm going to give you a better example still than that, because this is what this fellow comes up with. This is where he got it. Here's a series of 3 examples. The first one's going to be a plumb bob. the fellow's going to hang a plumb bob. You know what they used to measure the walls, like that the wall is straight. The masons, and he's going to put a plumb bob in his car. So he's going to accelerate. So what do you think is going to happen? Well, the plumb bob's going to go back. Okay, it's like you standing on a car, just standing, or on a train, right? You're not hanging on to anything. The train accelerates. Are you going to go in the forward direction? Or are you going to
go flying back?
We all know you're going to go flying back. Okay, same thing with a plumb bob. He hangs it, okay? Yeah. He accelerates the car. He shows that the plumb bob goes backwards. He replaces the plumb bob. He's going to put a balloon, okay? The balloon does not go backward. The balloon goes forward, the opposite direction of the plumb bob. Yeah. So we're going to have to explain this. Well, what happened there? Why did the plumb bob go backwards? How did the balloon go forward? Okay,
the air molecules go to the back, so the balloon goes forward.
Okay, we'll get to that. And then the last example, 3 examples. The last one is probably the best one, really. He puts water in a jar. Okay, he fills it up with water, but he leaves a little bit of air in the jar. So he has the jar, instead of up down, he has it sideways. So you see the bubble of air inside the jar. If you move that forward, the water goes to the back, pushing the bubble to the front. Okay? He's saying that's what's happening in the balloon. When you accelerate the car, the air in the car goes to the back of the car, and that's why the balloon is pushed forward. Okay? That's the explanation. Okay, so let's go through each one so that you visualize what I just said. Okay,
well, it's more of a description than an explanation.
Yeah. It's so far we have we'll get to that. Well, I'm going to get to that. Okay, so let's go with a plumb bob first. I think everybody is familiar with what would happen to a plumb bob. Here it is. Okay, so he accelerates the car. Okay, you'll see it in a second here. And as soon as he accelerates, the plumb bob goes backward. Okay, straightforward. You think you would see the same thing if you did this experiment at home? Yep. Yes, you would see the same thing. You hang this plumb bob there, it would go to the back. It's like when you accelerate the car, you get stuck to your seat. Exactly like that. No different than that. Okay, and that's even, the air went to the back of the car and didn't push you forward for some reason. I don't know why. Or the plumb bob for that. Just the balloon. Okay, we'll get to that. And here's the balloon. Okay, same thing. Okay, he accelerates the car, and instead of the balloon going backwards as, intuition would tell you, common sense would tell you that, hey, maybe the balloon should act like the plumb bob. No, when he accelerates, the balloon goes forward. Very strange, very counterintuitive, right? Okay, now let's look at the air bubble inside the jar. Okay, here it is. Okay, make sure you understand that. He's got the bubble there. As soon as he accelerates it forward, you can see the water goes back and pushes the bubble forward. Okay, do we understand that? That's the issue. Okay, so this is what the flat earthers have in the back of their mind when they talk about density. And so the guy says something along those lines. He says, look, from this postulation, I can say that what you refer to as gravity is just deceleration. Okay, again, unsubstantiated statement, just he's saying it's deceleration. So far, he hasn't explained the cause, the mechanism, the physical objects involved in the word density. That's the issue that we've got before us. It's an explanation, no it ain't, okay, of direction, vector, weight, and density layers. No, that's a description. It's not an explanation. And again, it's all these people who don't understand the difference between an explanation and a description. So far, he hasn't explained anything. In order to explain, you need the mechanism. In order to get the mechanism, you need to identify the physical objects involved in this phenomenon called density. Okay, I'll get to that in a second. Even Einstein showed this in his equivalence principle. To mention Einstein, you're not going to persuade the jury.
Yeah, it's just authority.
You're just, and second, no flat earther believes in Einstein anyway, so why bring Einstein into this at all? Here, for sure.
That's like an olive branch to the Einstein lovers. Hey, join us.
Here in this channel, we clean our nose holes with Einstein and anything he ever said. Einstein didn't come up with anything. Okay?
But you're saying that his description doesn't count as an explanation because he hasn't established the objects yet.
And I'll get to that. I'll be more specific in a minute. Give me a second. Let me just go through this. No way for us to tell whether we are in a uniform gravitational field. What is a field? Field, you mean like a football field? Yeah. Which none can define or demonstrate. Again, talking about demonstration, doing a little experiment on your desk, right? Or in a uniformly moving reference frame. Again, I don't know what a reference frame is. I think he's talking about the frame of his picture on the wall. I have no idea what a reference frame is. No such physical object in physics. Only one of these can be shown practically. Again, he wants a practical demonstration using what? Classical mechanics.
Well, that's fine, and to use that to extrapolate to the greater world, you do that too with your rope.
Yeah.
I mean, that's fine, but again, if he hasn't established all the objects, then it's a different thing.
And that's where I'm going to get to, okay? This is where the issue is. And so here's a $1 million question for any flat earther, okay? But people aren't listening. That's the problem. I can't get them to listen to the question.
Yeah.
I just want them to answer the question, okay? And unless you pay attention to the question, you don't know what you got to answer. And right now, this fellow hasn't answered the question. Again, typical flat earther, okay? Answer the question that is being asked before you, okay? That's what we want. What is the question? Okay, here it is. $1 million question that we want all flat earthers to answer, okay? The car accelerates. You have density in the first in the throughout the car, right? And then as the car moves forward, the density close to the balloon, right, is or in the front of the car is less. That's what they're saying. Air is less, and in the back of the car, it's more. Okay, so we have higher density, and that's why the balloon goes forward. Okay, that's the explanation. Here's a $1 million question. Why? What causes the air to accumulate in the back of the car? What's pulling or pushing on each air molecule towards the back of the car? I'll give you a better one that you can probably visualize a little better, and I pretty much covered it already, but you're standing on a train. You're standing on an airplane. You're standing on a truck. I don't care. Or a bus. You're not hanging on to anything. Your feet are touching the ground, right? Okay, so now the vehicle, whichever one of these that you choose, accelerates. What happens to you? Do you go forward or do you go backward? Well, we all know that, from experience, we're going to go backwards, right? Okay, so we go backwards.
You're talking about inertia.
Inertia, right? Density, air density, maybe, I don't know. Why did you go backwards? What's pushing or pulling on you? I mean, for example, let me show you something. Here's a magic wand. This is Bill's magic wand, right? Let's say this is simply standing in the air somehow, in the car. Let's say it's just floating in the air, like a balloon.
Yeah.
The car accelerates. This, let's assume, stands still, more or less, right? The car accelerated, and this stands still. It didn't take it with. Or let's say it's in this room, right? It's not touching the floor, okay, somehow. And the room accelerates. This would stand still, and you say, well, that's why it came closer to the back wall. Like in the case of the car accelerates, or the airplane accelerates, you're just standing there, you're going to get closer to the bathroom in the back of the airplane. Why? Because you say, well, because, you're standing in midair, and the airplane accelerates, so you go backwards. But we're not talking about that. We're talking about you making contact with the floor of the airplane. Your feet are touching the floor of the airplane. The airplane accelerates. Should you be accelerating together with the airplane? I mean, you're in direct contact with the floor of the airplane. What is pushing or pulling you backwards in the opposite direction of the airplane? What is in physical contact with your body is what I want you to not only tell me, but draw and illustrate. I want you to illustrate the invisible, intangible objects that are in contact with your body.
Wait, what's the difference between the floating stick and the standing?
Well, the issue is the following. You have a fly. Or a little bird, right? It's flying in the airplane. So the airplane moves forward. Well, we can imagine, right, that maybe with respect to the walls of the inside walls of the airplane, right? If we were to film that, well, maybe the plane goes forward and the bird goes backward with respect to the airplane. Okay, let's assume that's the case. And people would say, well, yeah, because it's not in contact with the airplane. My point here is that if you are standing on the airplane, why do you go back now? Now you should go together with the airplane.
Should you?
Huh?
Why would you? You're not a part of the plane, so why would you?
Well, because you're in contact with the airplane.
Yeah,
I mean, why doesn't the seat go back? The seat, that where you sit, that one goes with the airplane.
Well, it tries to.
Well, yeah, but that one goes with the airplane. I mean,
no, but it tries to go back.
I know, but this is the point. The point is that I'm in contact with the airplane, right? I'm standing directly with the airplane. Why doesn't it, like a tree that's planted in the ground, if you move the ground, the tree would go with the ground because, it's stuck to the ground, right? More or less like that. I'm saying that, you're stuck to not stuck completely, but you're in contact with the airplane, with the surface of the airplane. Why do you go backwards? What's this inertia thing? Don't tell me density, don't tell me inertia. Don't use any of the concepts. I need a physical object that's in contact with you, that's pulling or pushing on you. Okay, that's what I want. I want you to draw, illustrate, show me anywhere on the internet the physical object that is pushing or pulling on you when the airplane accelerates. That's the question. Okay, you have to identify that. Otherwise, you don't have an explanation. You can't talk about gravity. You can't talk about density. You can't talk about any of these concepts because you don't understand them. You can't tell me the mechanism of what's pulling or pushing you back towards the back of the airplane or the back of the truck.
I don't like that phrasing. It's not really pushing or pulling you. It's the plane that's going forward, and you're just standing.
Why am I going backwards? Something is
You're
in
not
contact
going
with my
backwards.
body.
The plane is going forward, I thought.
Yeah, but I'm in contact. See, with a fly, you can say the fly is not in contact with the airplane, but I'm in contact with the
But
airplane.
that doesn't change anything.
Why?
Why would it?
Why wouldn't it? Why wouldn't it? What's
Why would it is a weirder
no,
question.
no,
That's the
because,
real question.
No,
Why
no.
would it?
Why wouldn't it is the question. I need to know the physical object that's in contact because
you're
the
not
airplane is in contact with my feet. So you would think that has more influence than the invisible stuff that is pushing or pulling me backwards. Because if I'm in contact with a floor, you would think that I would move together with a floor. Why not?
You're not glued.
Why not? Well, I'm not glued. So what? So what if I'm not glued? Why do I go backward is the question.
But you're not going backward.
I'm going backward.
The plane's going forward.
With respect to the airplane, I'm going backwards. I'm going to the back wall of the airplane.
But the plane's going forward.
Well, I don't care. I'm saying, why am I going backwards with respect to the plane? Why don't I move with the plane?
Because you're not glued to it.
Yeah, I know. So what? What's keeping me from going? What's keeping me from going together with the airplane, with a bus, with a train? That's the question.
That's a weird phrase. That's a loaded
Well,
question.
no, it's not a loaded question. You need to
no.
identify the physical object that's in contact with my body. There is something in contact with my body, and that's what we're going to get to next. Here, we're going to see that. Okay. In other words, here's my explanation. Okay. This is again my explanation, so that you see where I'm coming from for this issue. Okay. First of all, you can't use any of these to explain what I just asked. In other words, what's in contact with my body? You can't use the word weight, mass, density, deceleration, reference frame, demonstrate, experiment, practical, none of that.
Because they have no meaning.
Yeah, what we want is the physical object. I want you to draw it.
Yeah.
I want you to illustrate the invisible object that's in contact with my body, with every atom.
Show the movie is more specific.
Well, yeah, because when I say, for example, when these people say that air goes to the back of the car, what is pulling or pushing on each atom, each molecule of air? What is pulling or pushing on? Why does it stay, or why doesn't it stay where it's at, or why doesn't it travel together with the car? Why does the density accumulate in the back of the car? That's the question. What's pulling or pushing on each molecule of air? Okay? And if you say there's nothing there because you can't see it, I don't care. That means that you don't have a mechanism, you don't have an explanation for density, which is what I'm asking you to explain. I want to see the mechanism. Mechanism means objects, means you have to identify the invisible objects that are in contact with air, which is, by the way, also invisible. Why does the air accumulate in the back of the car? That's the question. Not say it does, and because of that, the balloon moves forward. No, tell me why the air goes to the back of the room, of the back of the car. That's the question. Okay, let's get it right. Okay, so how do we answer this? Well, we start with this, which is our interconnected universe. Okay, we're saying that all atoms in the universe, all atoms in existence, are physically interconnected. An atom is attached to any other atom in the universe. Everything is physically interconnected. We start with the single thread, which turns into a rope, which interconnects any two atoms. Okay, and once we have this, we can see why there is no action at a distance. It's just that we cannot see what's between the chair and the table. That's what it is. We can't see what is connecting the atoms of the chair to the atoms of the table. Okay, that's the issue before us. And if you're going to do it without an interconnection, if you're saying there's nothing there because you cannot see or touch it, then all you are doing is black magic. You're saying that this atom over here affects that one over there, and there's nothing in between them. You're doing the same thing as quantum mechanics. They explain everything with action at a distance. Gravity, action at a distance. Magnetism, action at a distance. Okay? Why? Because here we have two magnets, okay? Two little round ones there, okay? And you can see that one attracts the other. See if you can put your hand between there. Did you hit anything? Did you touch anything?
I think so. Air.
So you can't see or touch anything that's between the two magnets. So how is this magnet affecting that one such that, I can already see, if I hold them very lightly, I can. See there, it's already pulling on the inside. No matter what I do, there's something on the inside that's pulling them together. We can't see it, we can't touch it, it's there. There's a physical object in there. You say there's nothing there because you can't see or touch it, you're doing black magic. You're explaining this with black magic. You might as well use spirits and say, well, the spirits did it, or God with his magic wand. You can do whatever you want because you're talking about black magic.
Yeah, the field doesn't mean anything. When they say magnetic field, they're like,
it's a concept.
What is it?
Yeah, you got to
just say, in this area, something's happening. Oh, great. Yeah, I got come up with that.
That is what the word field meant. When Faraday invented the word field, I think it was 1845. Some people have traced it that far back. 1845, he invents this word field. What is the word field? Well, as far as he was concerned, he dealt with electricity and magnets. He said, look, there's a region in there, and there's something in there, the lines of force. We can't see or touch it. There's some exotic matter there that we can't see or touch, but there's something there.
And we can sprinkle iron filings to know which direction motion is going, but we don't know what what is causing the motion.
And you said it right there. You throw iron filings. Are you saying that nothing compelled the iron filings to line up in a certain way around a magnet?
Well, the field, but that's the same
area. Yeah, that's a region.
Yeah.
All you're saying is, what is a field? Field is defined by mathematicians as value at each point in space. All they're talking about is numbers. They're saying there's a certain strength at different distances. That's all they're saying. So field is just a bunch of numbers.
Okay,
you can't say the field moved the wall.
But back to this. So why am I not carried by the plane when the plane accelerates forward?
Okay, so here's my explanation. If every atom in the universe is connected to all others, here I show an example why the Earth is round, spherical, not flat. Okay, so is every other celestial object out there. I would say 99% of celestial objects in the universe are spherical. Moon is spherical, sun is spherical, all of them are spherical. Why? Because of gravity. What is gravity? Gravity is that every atom in the universe is physically interconnected with all others.
I guess gravity is a symptom of that.
Yeah, it's the result or the result of gravity, right? Or the word we use to express why everything tends, like in this case, towards the center. Mm-hmm. Because if you have water, which is the blue part, the very dark blue, and then you have air, which is the light blue layers there. Well, if you have an atom in air, it's pulled towards the center of the Earth because that's where most of the matter is concentrated at. So all these atoms that you see on the periphery that I drew there, you can see they're all essentially tugged towards the center, and that will describe a ball. Okay, that's what you're going to get if you have this notion of gravity. Okay, so I can explain why everything falls towards the center of the Earth, because all atoms are physically interconnected and there is no action at a distance, as the flat earthers would have you believe, because they can't see or touch the mediators, and we're not going to be able to see them in the lab. We're not going to be able to demonstrate, run an experiment where we prove, which is something related to belief, prove to the jurors, to the jury, that there is something there between any two atoms. There's no way you can prove that because it's invisible and intangible. Yeah. Therefore, experiments will not help us at all. You cannot prove gravity with experiments.
Well, so you can prove it to some people. But we're not interested in proving it.
First of all, we're not interested in proving. Second, I don't think you can prove. What are you going to prove for invisible, intangible?
Well, proving is
prove to me that there's something between two.
No, but you're not getting it. Proving is the fault of the person who's it proved to. You can prove whatever you want, depends on who you're talking to. If you talk to a guy in the street, I can prove anything.
Yeah. In other words, you're addressing belief. You're not addressing understanding. What we want is understanding, not belief, not knowledge, you know.
Do flat earthers believe in flight?
Well, flight, I guess they believe in, because I'm sure flat earthers fly on airplanes.
Airplanes, yeah.
Yeah, I think they just don't think that the airplane goes out there. Yeah,
they don't go the extra mile. Okay, gotcha.
Okay, so a fellow says, okay, I showed him how to curve water. You curve water out there in space. You can't curve water here in a glass.
I think that was actually a question I wrote here. Are the edges of the cup of the water lower than the center ones? Like if you went in there with a like nanoscope,
well,
would it be a little bit curved?
Yeah, of course. Yeah, if you could look at each atom individually, the edges should be curved. Yeah,
assuming the Earth is round.
But they say you're cheating because that's not our everyday experience. So you're going with SEMs and atomic force microscopes, and it's beyond our.
That's cheating. You're doing some tricks.
You're using something we have no access to every day, and so I don't believe in that. That's the way they answer that. Okay, so the fellow says makes this comment. He says the following. He says the question and the observation is about how water behaves here on Earth in our reference frame. Again, he wants this. This is the extent of his experience. He says, look, here I can show you it's flat. That's it. He says, I'm not going to go beyond this. That's the extent of his understanding of his ignorance, maybe.
But it isn't. That's kind of he's wrong, but off the get-go. That isn't flat.
No, but assuming it's completely flat, let's concede it's flat. I mean, irrelevant. I mean, this is not the experiment to prove that water curves.
It is for him.
Yeah,
that's why proving is the problem. That's why proving is the problem.
That's why we don't prove in science. In science, proof means that you're going to believe, and you can believe anything you want. I don't care. Yeah, you can believe the Earth is flat.
Anytime someone says it's been proven, the question always remains to whom?
To whom has it been proven? To the Pope, the Dalai Lama, you know? Okay, so he says, Bill's reasoning is to jump to a reference frame that he sees on TV that is not within our reference frame. No, what I'm saying is it's got nothing to do with TV. It's got to do with, I mean, here you have the moon. Is this a paper moon that we have out there, a flat moon that we have out there in space?
They say it is.
You know, I mean, are we talking about a flat moon, a flat disk that's out there floating, or do you think the moon is spherical? Do you think the sun is spherical, or is it a flat disk?
Yeah, it's the flat Moonies too.
Paper moon.
Well, that's the other question. Why does if the Earth is going up the whole time, why does it never crash into the moon or the sun? They never explained that one either.
Yeah. Anyways, so the question is, this is not a question of me seeing something on TV. This has to do with visualization. You should be able to visualize, to say, close your eyes and imagine how Mother Nature, Father Universe, God, the devil, whoever you believe in, how they could be doing gravity. That's the issue. Okay? And so we say, look, the moon is spherical. The sun is spherical. All objects out there are spherical. Now, if you have problems with that, you think everything's just a flat disk floating up there, Jupiter and whatever, or Jupiter's too far away for your understanding, you don't care about that, well, then we got problems, because all you're doing is enclosing yourself within your ignorance. You're saying, oh, I'm not going to look through Galileo's scope to verify that there are 4 Galilean moons out there.
It wouldn't even work if the moon were flat, because if you look at it from different angles, it wouldn't be a circle, right?
No, but I guess, see, they say that the moon is just flat, and you're just staring at a flat disk.
But
I think that's, I don't know.
If it's a circle, and you're looking at it from an angle, it would be an oval.
Yeah, that's another one. But you can,
like basic optics. That's basic optics.
So he says, even if I grant that it is a real reference frame, it's got nothing to do with how things behave here in our shared reality. Again, he wants to bring us back to Earth, just a little lab, what he did maybe in high school or elementary school. He says, I just want to limit my understanding to what's inside my little room. I want to be able to, mix liquids. And
that is there. I mean, the only way the moon and let's just take the moon as an example. The only way that could be a circle, that could be seen as a circle from anywhere you stand on the Earth, assuming the Earth were flat, is if the moon were a sphere. Otherwise, you'd see weird ovals in different shapes.
Yeah.
So
that's
just by their own logic, it falls apart.
So he says, you are ignoring direct demonstration. He wants a demonstration of gravity. Okay, well, here's a demonstration of gravity, okay? How's that? There's a demonstration of gravity. Did you see what caused the wand to fall downwards? Okay, so yeah, it's these people are asking for something that's irrational. They're asking to see that which is invisible and intangible. They say, I want to see it, I want to touch it, I want to run an experiment, I want you to demonstrate. So what are you going to, so, here's a pencil, right? I'm going to let go of it, it's going to fall to the floor. We all know that. But see, can you see or touch anything that's in this region? That's the question. And if you say there's nothing there, you're explaining this experiment, you're explaining it with black magic.
Is that the reason
you can't use the word density?
Why you rejected the see and touch notion? Because, I mean, even magnetism, for example, there's no way to touch or see the actors in the field.
Exactly.
So seeing and touching is just a bad measure of telling what is acting upon things. And is that why you had to come up with the shape thing?
No, because really that came afterwards. The explanation say, no, these people are harping. I was saying, what is the problem? The problem is that all these people, including the mathematicians, the mathematical physicists, the electric universe, the flat earthers, the John Chappell Society, all these people are talking about see and touch, experiment, demonstration, proof.
But what's wrong with...
You can't do that because an object is not that which you can see and touch. And existence is not that which you can see or touch. You can't say the chair exists because I can see and touch it. That's an irrational statement. The chair exists by definition whether you can see or touch it or not. And people don't understand. That's where the problem is. Well, they have the wrong definition of the word object and the wrong definition or irrational definitions of the word exist.
Well, it also falls apart when if you were to assume there are objects that do exist, however you define exist, that are untouchable and unseeable, then you got a problem just by your own definitions. Not by yours, I'm saying.
In other words,
if someone says exist to see and touch, but if we just assume that there are things that exist that you can't see and touch, then you got a problem. Because then does it exist or doesn't it?
Yeah, and we're going to see that in a couple of questions that come up here. People think that an object is that which you can see or touch. And existence is also that which you can see or touch, meaning that the word exists and the word object are synonyms in their minds. They can only deal with that which they can see or touch. Turns out you can't see the air. You can touch it, but you can't see it. So it already failed one of the criteria. You can say, well, I can touch it. Okay, what did you touch? If you can't see it, what is it? Maybe you touch a spirit. I mean, I don't know what you touch, but forget about that. Can you see or touch the table that the Klingon has on the other side of the universe?
And so you believe in Klingons, is what you're saying. and who can see and touch? Because it might be a dead guy, or it might be a blind guy, or it might be a guy in a coma. Can that guy touch it? I mean,
well, you can't see or touch the individual atoms that make up your table. You can see or touch the table because it's made out of gazillions atoms. But you can't see individual atoms. You can't say, oh, I can see or touch a hydrogen atom that's made that makes up part of my table. You can't do that. You can't see or touch it. You can't see it with a atomic force microscope. You cannot see it with a SEM, scanning electron microscope. You can't see it.
Technically, I see it. It's just really low resolution, right?
No, no, you can't. Not a hydrogen atom. You can see a bigger atom, but you can't see a hydrogen atom. And the atoms that we can see with a SEM or with an atomic force microscope are from a bird's eye perspective. All they see is a little balloon there. That's it. That we've never seen the little bead rolling around in the orbital. Okay, we haven't seen that. We haven't seen a bead going around the electron, So that we've never seen. What we see is a balloon, like from a bird's eye perspective. And they say that's an atom. Okay, great. What did we see? What did we stare at? Can we see in the center of that atom and find out what the proton looks like? Obviously not. Okay, we can't see a proton. Okay, so the question is, does that mean that there is no such thing as a proton? Does it mean that it doesn't exist because you can't see or touch it?
Well, that's the problem with see and touch. The biggest problem I see with that is whenever object facilitates or is the cause of sight, just sight as such, cannot be seen.
The object itself that causes that or that mediates that, of course you can't see it. You can't see the mediator of light.
Yeah, because
you're actually to see the mediator of the thing that you're using to see it.
Yeah. So that one you have to use your brain for.
You got to imagine these days. You can't say, let's go to the lab. And let's see and touch it. Let's run it.
By definition,
you're You're making an irrational statement. And flat earthers want demonstration, proof, experiments. And so do the Electric Universe and all these other people like John Chappelle.
Why do you keep beating up on the flat earthers? What did they ever do to you? What's the obsession with them?
Okay, so here's the comment the guy makes. He said, Bill should learn the difference between microscopic and invisible. He doesn't like the fact that an object is that which you can, that has shape. He says he wants to say that an object is that which you can see or touch. Okay, and so the question here, he says, should learn the difference between microscopic and invisible. He thinks that all objects have can be seen or touched, but some are just very microscopic, not invisible. Okay, so he's saying that an atom, a hydrogen atom, is not really invisible to our eyes. It's just microscopic. That's his argument. There is no such thing as invisible or intangible objects. Well, what's the mediator of light? What's the mediator of gravity? Here's gravity. Okay, let me push this out for a second here.
Are we going to see gravity again?
We're going to see gravity again here.
We're going to see the effects of gravity. Let's be
here we have a pencil, okay? Do you see or can you touch?
One of these days it's going to fly up.
They say I break too many lead in the pencil. All my pencils are broken from dropping them so much. Okay, so can you see anything above or below the pencil? Can you touch anything other than the air above or below the pencil? What's causing this to happen? Why didn't it fall to the ceiling? And there's something that is in contact with the skin of this pencil. If you say there's nothing, no physical object, nothing that exists that is causing this to happen, you are introducing black magic. You're saying that this happens by action at a distance. The earth has some magical influence over this and pulls it down. And you cannot say density, weight, a reference frame, none of that. You need a physical object. You have to tell me what physical object is in contact with a pencil.
You keep throwing it down. That's what it is. You're cheating.
Okay, let me throw it up. Ah, it still falls down.
Trick shot. That's
your theory failed. Okay. Okay, so the fellow says, no such thing as invisible, intangible object. He says atoms are microscopic, not invisible. Yeah, correct. We're not saying they're invisible, but we can't see them except with some kind of device, right? If something can't be seen or touched by an instrument known to man, like dark matter or electromagnetic waves, there is no reason to assume it exists.
If it can't be seen or touched, there's no reason
to assume it exists. He rejects it out of his experience.
Wow, he dies on that hill.
Yeah.
He chooses to die on the see and touch hill. If it can't be touched or seen, then it doesn't exist.
Not only it doesn't exist, not even an object. It's not a thing.
Yeah. It's not even.
Okay. If you can't see or touch it, see that's the. And another fellow says no such thing as invisible, intangible, physical objects. Invisible, intangible object is an oxymoron that can't be true. Okay, and again, what is the problem? The problem is that these people are running with an irrational definition of the word object, of what a thing is.
Wait.
Yeah.
Black holes, those also can't be seen or touched.
Well, black hole has a different problem because, see, we define an object as that which has shape.
No. I mean by their own definition.
Oh yeah, you can't see or touch it.
So
yeah, but see, the flat earthers, you're talking to the wall because they don't believe in black holes either, which is correct.
Well, I mean,
they're intelligent in that sense. Okay, yeah, no black holes. Okay, so here we have it. Okay, and again, an object is that which has according to the flat earthers and all these other people, they think it's that which you can see or touch. But it's an irrational definition because we cannot see all objects, we cannot touch all objects. Certainly we cannot touch that planet that's on the other side of the universe or the table that the Klingon has on the other side of the universe. Is the word table, does that refer to an object? Yes or no? Does a table exist if the Klingon is on the other side of the universe putting his coffee cup on the table?
But he can see and touch it.
Yeah, but I can't. So for me, it doesn't exist. For him, it exists.
Call the Klingon.
Yeah, but
hey, hang on, that table exists or not, dude?
But see, the problem is, then we say, well, for him it exists, but for me it doesn't.
No, man, now we're getting into weird territory.
Yeah, because what do you mean? It exists for him, it doesn't exist for me. Yeah, I mean, either the table exists or doesn't in the universe.
Well, I mean, some people would postulate, philosophers among others, that what existence is subjective, so your existence is different than my existence, etc.
Not true in physics. In physics, we define the word exist so that all objects in the universe that are there exist. And it has nothing to do with see or with touch. You can't run an experiment to prove what exists. Okay, that's where the error is of Flatlanders.
I guess the answer to that would be, before there was consciousness on Earth, the moon and sun still were. So they're independent of our seeing them.
Exactly. No, but you probably would have to argue with them all day long, and they might say, well, no, they began to exist as soon as we opened our eyes.
I mean, they're obviously older than we are.
Well, you can imagine the blind man who's deaf, poor guy, for him the moon doesn't exist, right? So for him, he can't say, well, the moon exists because of this definition. He has to see and touch it. He can't see or touch it. For him, the moon doesn't exist. For you, it exists, but for him, it doesn't.
But the guy can feel the waves of the ocean, which are caused by...
Well, caused by God. I don't know. Maybe spirits. I don't know. Who knows what causes that? Newton was wrong. Nothing to do with the moon. Okay, so here we have the definition. Exists. Physical presence. That's what the word exist means. What does physical mean? Object. What does presence mean? Location. What is an object? That which has shape. What is location? The set of distances from one object to all the rest in the system under analysis. So if God wants to exist, first he's got to be an object. God cannot be a concept like love or spirit.
He has to have shape.
Yeah, he has to have shape, according to that definition. And then that's not enough if he wants to exist. He needs something else, which is location. Set of distances to the tree, the rock, the table, etc., everything in the universe.
You mean
we do not use any of the senses. The only sense is common sense, the least common of all senses.
True. But I guess by this definition, if God does exist, he's findable. We'll find him.
In fact, we don't have to find him. He exists by definition.
Yeah.
If there's distance between my chest and his chest, he exists by definition.
Even if we don't know where he is.
Yeah, I don't have to touch him. I don't have to see him. He can be in the 25th dimension for all we care. As long as there's a straight line of direction from me to him, he exists. We're done. By definition. By definition, the word exists. And that applies to any object in the universe. So this notion that an object is that which you can see, touch, exists is that which you can see, touch, that's where the irrationality of the flat earthers, mathematical physics, electric universe, John Chappelle Society, all these people have it wrong. They have it irrational. They think an object is that which you can see or touch. No, it ain't. That's an irrational definition. Okay, so here we have a situation. This is a spoon falling, okay? This is what I'm going to show you, okay? Here's the spoon, we're going to let it go, okay? It's going to fall to the ground, okay? That's very, very dangerous experiment. Don't do it unless you're in the presence of a relativist, okay?
I'm the relativist.
At home, yeah, okay. So I can do it. So here's the spoon. This is what you would see. Just do it at home. Just let go of a spoon, always in the presence of a relativist, right? And you can see that you cannot see what's below or above the spoon. All you see is the spoon falling to the floor, okay? That's all you see. What are we saying? Where are we saying that this is what's happening? Every atom of the spoon is connected to every atom on Earth. Of course, I didn't draw all the connections there. You have to imagine that it's gazillions of atoms.
That already looks like a lot of work.
Yeah, so all we have is just a spoon falling because every atom that makes up the spoon is connected to every single atom on Earth. In fact, to every atom that comprises your body.
That looks kind of cool, actually.
Okay, so this is our explanation of why a spoon falls to the floor. No density, no weight, no abstract concepts. There's a physical object connecting every atom on Earth to every atom of the spoon. That's why the spoon falls. As it falls, the reason it accelerates is the ropes, in this case, which are the mediators, widen. They open up, and so they're not all on the same axis. Now they form new axes as the spoon gets closer and closer to the center of the Earth. That's the explanation that we give for gravity. We don't care if you believe it. We want you to understand what I just said. Okay, we want you to understand the mechanism of what we're proposing for gravity. So don't tell me you don't believe it. What about these ropes? And we don't care about all that. Do you understand what I just explained? Why? What causes the spoon to fall to the floor? Every atom is connected to the earth, and as it falls, the ropes are not pulling, but there are more ropes that are not on the same axis, okay? Because they're widening out, they're fanning out. That's what's happening. Mm-hmm. So you have not more ropes, but you have more ropes on different angles.
Yeah.
That's what we're saying, because every atom is connected. Just visualize what I'm saying, and you're going to understand the mechanism. All we want you to do is understand the mechanism. We don't care if you believe it or not. It's not important.
Well, it still begs a lot of questions, but
there's
a lot to unpack. For example...
But we have to start by understanding.
Yeah, but there's a lot that you have to unpack to understand it. For example, it's also proximity-based, because there's a lot of atoms on the other side of that spoon that we're not taking into account. So
there's a lot of questions, and it's a question of distance there, so we're not going to get into the details. All I'm saying is try to understand before we kill you.
That's the simple explanation.
That's a very simple explanation. As the spoon gets closer and closer to the center of the global Earth, right, the ropes fan out. That's it. That's all you have to understand. If you understood it, we're done. You believe it or not, that's something talk to your priest on Sunday, okay? Sunday school, okay? Okay, so what are we saying? Here we have it again. One more time just so that we rub it in. Here's the spoon, okay? It's standing in midair. What is happening? Well, what is happening is the spoon is going to fall to the floor, okay? And where is that floor? Well, the floor is sitting on the earth. Now, I drew a global earth. You can draw a flat earth. We don't care. But the floor, hopefully, is on the earth, right? I hope the flat earthers at least agree with that, right?
We're going step by step.
Okay, we go very baby steps here. Are you
dropping it from space like that?
Yeah, okay. So we're going to draw. Now, this is inside the room, but all I'm saying here is the floor is on the earth. Now, the earth could be flat or curved. It doesn't matter. Hopefully, the floor is on the earth, okay? So what are we saying? Under the rope model, we're saying that every atom of the spoon is connected to every atom of the floor and of the earth. Okay, that's the mechanism we're proposing. We want you just to understand, okay? Just understand what we're saying, okay? We don't want you to believe it. We don't want you to, be convinced. We just want you to understand what we're saying, that every atom of the spoon is connected to every atom on Earth, and therefore it has to be a global Earth. Okay, it can't be a flat Earth. Okay, so now we have, where did we get this? Here we have Mr. Muller. He's a professor at...
authority, hey.
Yeah, here we have authority, but all he's going to do is regurgitate the law of gravity from a mathematical point of view, and this is what his conclusion into physics, how he draws that into physics. He's saying that, so for example, if you have the Earth, there's a big mass here, and you can see he drew the big M there, a little circle, right? That's the Earth. And you have you with your little mass here, and that's you standing on the Earth, right? Every atom on the Earth is pulling on every atom of you. You're also pulling on it. Okay, so that means that if you're pulling on every atom on Earth, that means every atom of your body is connected, physically connected somehow, to every atom in the Earth. Okay, do we have that? The amazing thing about gravity is that it goes right through things. It goes through things. The only way you can explain that is if every atom in your body is connected to every atom on Earth. So it doesn't matter if there's an atom in front of the other atom. It goes right through both of them because you're connected to both atoms. That's what we're saying here. Okay, so that's where we got it. And this explains Newton's universal law. Okay, and I'll get to that in a minute because a fellow asked that question. Okay, so here we have it. That's in a nutshell what we have for the flat earthers. The flat earthers should not request demonstrations, proofs, experiments. We're not going to prove the invisible, intangible with any of those.
We just did.
And you cannot explain using the word density, weight. I don't know, a frame of reference. You can't use those concepts. You have to draw the physical object, invisible object that is mediating the transaction.
Are you saying that instead of using density, they should use every ball atom in the air?
No, all I'm saying is, if you're going to say that the car moves forward, and because of that, the air moves to the back of the car, and that's what pushes the balloon forward, fine, no problem. You have to explain why the air went backward, and why there's higher density in the back of the room. That's what we need to find out.
Yeah, they'll just say that's how density works.
You cannot just say that's just density. You have to say why. What caused each atom, each molecule of air to go to the back of the car? That's what you got to explain. And that's so something pushed or pulled on the air with respect to the car. The car went forward, the air went backwards. Why? Why did the air go backward? I accelerated the car. I did not touch the air. Okay, so why did the air go back? And I'm saying that every molecule of air is connected to every atom on Earth. So it's like a tree. Okay, the tree is on the ground. When the car moves forward, The trees don't move with the car because they're stuck to the ground. So with respect to the car, the trees are in the back, right? That's what I'm saying. And that's what's happening exactly with the molecules. The molecules accumulate in the back because they're tied to the earth.
Okay, but that's what makes it sound like a loaded question, because you're basically answering a question that nobody had, but it was a question. Because everyone took that for granted, the inertia thing. Everyone kind of takes it for granted. Oh yeah, if the plane goes forward, everything goes back. But you're saying, no, there's a reason for that.
Right.
It isn't just
you gotta have a cause.
I mean, on some level, some people, at that level of abstraction, people go, oh, that's just how it is. But you're saying, no, there's a reason for that.
Right,
you're answering a question that no one had.
Right.
That's why it sounds like a loaded question.
Right.
The way you ask the question makes it seem...
People just go with descriptions. That's the problem.
Well, no, because at some point you have to say that's just how it is.
No. This is the issue. The issue is that people just measure, and they say, well, there's more density here than over there. But you haven't answered the question. All you have is a description saying, well, yeah, there's more air over here than over there. But you haven't explained why is there more air over here.
Well, yeah, but inertia is the that's just how it is part. That's where their logic bottoms out. Yeah. But you do that too. At some point, you have to say that's just how it is. Why is the rope, the shape that it is? Oh, that's just how it is. At some point,
but that's different than saying that because you're explaining the cause, and that's where it all ends. That is the last question.
That's what I mean.
The last question. Hold it. Let me finish that. Okay. The last question is, why does the air move to the back? Because it's stuck to the earth. Now you can say, why is it stuck to the earth? That's an irrational question. And it takes a long time to explain that to people. You're asking a question of philosophy, which is reason, purpose, in the context of physics, which is causes and mechanisms. Well, that's where the problem is. It's not that the questions are endless. It's that now you entered into irrational questions. You're introducing philosophy, which is reasons and purposes. God did this because he had a headache, that sort of thing. Well, yeah, why did he do that? That's not part of physics. Physics is explain the mechanism. Yeah. The mechanism stops. The last question stops at the atom is connected to the earth. You understand that? Now you understand the mechanism.
Well, yeah, but they just stopped one before that.
Which is what?
Which is that's.
Oh yeah, they stopped. Right, yeah. They stopped the density inertia.
Yeah, that was enough for them. But you're like, no, there's a reason for that as well.
And that's the one they never figured out.
That's what I mean. You're answering the question that no one had.
Yeah,
because no one questioned the inertia thing.
No, and the reason, there's a reason for that as well, and that is because people can't see or touch what's there, so they say, well, we can't answer that question. Yeah. We'll never answer that question, which is wrong, because you have to visualize it. You're not going to run it through, you're not going to figure it out through an experiment. You're just going to have to visualize how Mother Nature's doing that phenomenon.